if I've got, these are both s squareds, right? So we can rewrite this as 14 s to the fourth minus what, 15 s squared? And can we factor that? I think we can. I'm going to factor out s squared. And that's going to leave me 14 s squared minus 15, right? And I can factor that as well, because it's, again, we can look at it as the difference of squares. You're like, that doesn't look like a squared minus b squared, right? This we can look at as a squared minus b squared, right? But we got to use our imagination. What's the a and what's the b? How about square root of 14 times s squared minus the square root of 15 squared? Look at it like that. Think of this as your quote-unquote a, and this is the quote-unquote b, you know? So if we do that, then we've got the square root of 14 s minus the square root of 15, square root of 14 s plus the square root of 15. There you go. That's as far as we can go. Why are we factoring, by the way? Like, what's the point in all this? You know? That brings us to our next topic. So the next topic in here, I mean, there's still a little bit more with factoring. I think I'm supposed to tell you about the special form trinomial. I'll do that next time. That's kind of more in the weeds, so to speak. But the bigger topic next is how do we solve polynomial equations, right? How do you solve? How to solve p of x equals to 0, where p is a polynomial, you know? So, for example, what if I wanted to solve, you know, y to the 8th minus, I'll use x rather, x to the 8th minus 4x to the 7th plus x minus 4 equals to 0. How would you solve that equation? You're like, ugh, maybe I wouldn't, I don't know. Well, the thing is, if we use factoring by grouping and follow example 9's pattern, this can be rewritten as x minus 4 times x to the 7th plus 1, following the pattern that we saw in example 9. And you're like, well, that's great. That still doesn't tell me what x is, right? But the thing is it does. Because one of the fundamental properties of real numbers is that if you have a product of two real numbers equal to 0, it must be what? Either one or the other, or both of those numbers have to be 0. You can't have like two real numbers multiplied together and get 0 unless one of those numbers is 0 itself, right? So that principle allows us to take a rather complicated problem and break it into much simpler subproblems. Like, instead of thinking about this product equal to 0, what I just told you logically frees me to consider two separate cases, right? Either x minus 4 equals to 0, or x to the 7th plus 1 equals to 0. Now, x minus 4 equal to 0, that, hey, we can solve that. That was a test 1 question, right? That says x equals to 4. You're like, I wish that was on test 1. Test 1 was not that easy. That's a lie. Like, it's false representation, right? My test 1 questions were like more complicated than that, weren't they? Yeah, I see some nodding. Good. However, admittedly, this is a little bit above our pay grade at the moment. But if we look at this as x to the 7th equals to minus 1, then we can take what's called the 7th root of both sides. And it turns out that that makes sense for and so like the 7th root of x to the 7th is x, and the 7th root of minus 1, you can put it into your calculator if you don't believe me, but if you calculate minus 1 to the 1/7 power, what you'll get is minus 1. So in fact, this equation right here, it has solutions 4 and minus 1. And those are all the real solutions. There are 6 other solutions which happen to be complex, but that's a different course. And anytime we have factoring, we can easily solve the corresponding equation. Here, I'll do it with an easier one. Like if we take example 11 and we set this equal to 0, what are the solutions to this equation? What is the solution? If we look at example 11 and put it equal to 0, what are the solutions? T equal to what and what? Has solutions t equals to 3 or t equals to 8? Because if you plug in 3 or if you plug in 8, we get back out 0 times something or something times 0. Either which way, we got 0. So what I'm trying to tell you is once we've factored the polynomial, we can easily solve the corresponding polynomial equation. And that's part of the reason we're interested in factoring. So, or we could learn the quadratic equation. Formula. Which I will get back to soon.
I'm saving y'all. I don't want to this long.
It's not that bad. I will instead of teaching you the quadratic formula, I will teach you how to become one with the quadratic formula and become the formula. Yes. Anyway, I think we're out of class time, so see you guys next week. Sound good? Maybe. You guys